All right, so let's do some more of these. Here, I want to find the name of the executable file the attacker uploaded to the server. So I'm going to use, again, post method, exclude the events from the vulnerability scanner, and look for the exe file name extension. So I've got most of that set up now. I got HTTP and post, and here's excluding the vulnerability scanner. So instead of this, which showed us the brute force attack, I just want to look for .exe. And there's only 2 such events, so if you look here, you can look through it all, but I know it's going to be an executable file, so the easiest thing to do is just use Control F and look for .exe. It only appears on the page a few times. There it is in my query. And here it is, 3791.exe. And this is pretty common. And if you keep going down, here it is again, the file name. This is the file name that was, so remember they downloaded an image and defaced the web page. They also downloaded a exe to put on the page to run. So this is, by the way, very common. If you use exploit kits and exploit websites and such, they'll just have a list of attack files to match your vulnerabilities. You run a vulnerability scan, then you say, what's the exploit? And they'll have these exe files available, usually with a code number like this, just to do it. So that's the name of the file that was brought down. And so they ran that file. So what they did is do a brute force attack until they gained administrator access. Then they were able to download the image and download the exe file, and then they ran the exe file. So the next thing to look at is a ransomware attack, which is a separate attack that happened other than the brute force attack and the defacement of the web server. So we're going to start by finding the IP address of this W8105 desk. So we start by just looking for the name of the desktop machine. And we're going to find a lot of events, so I'm going to filter this one. So let's just get rid of all this, search for that, and I'll just turn it to 1 to 100 to make it faster. Okay, so we find 1,800 events, which means there's 180,000 or so. That sounds right. So we look at the source field. Now we want to find the protocols used in Active Directory logins because we're trying to find the IP address of this machine. So if we look at the source field, you see there's an LDAP stream. And LDAP is Lightweight Directory Access Protocol. This is what's used to send login data when you log into a Microsoft Windows domain controller. And that data will likely include the information we need. So we'll look at the LDAP, and now I only have 1 event, so I'll get rid of the sampling to see them all. And there are 74 such events. And I want to find events on that day and look at their IP addresses. So I want events on 24 August 2016. Now, here's a timeline. So here's August 10 and here's August 25. These are the ones. I don't need these events. Those 26 are at the wrong day. These events are on the right day. I can just click the bar to limit myself to that day. That'll be those 48 events. And now I can see what's going on here. It's sending an assertion value. The name of your host is W8105 desk. So these are requests to the domain controller to log in. And here's the source IP, and here's the destination IP. And it's, unless you understand a lot about these SMB events more than I do, you wouldn't be sure which is which. But just from a normal naming convention, the IP address ending in 100 is typically the endpoint, the desktop, and the low-numbered IP, like 20, is probably the server. So the most likely arrangement would be this is the IP address of the desktop, and that other address is the address of the domain controller. And so that's what it is. This is the IP of W8105D, whatever it was. So that's a desktop. So I just wanted to find its IP address for starters. Now, I want to find Suricata signatures that detected the Cerber malware. This company did get ransomwared. So I'll start by Cerber. just the name of the ransomware. And there are a lot of events, 21,000 events. Now look at the source field and find the CircleCityCon events. So here's the source field, and the last one is CircleCityCon. There's only 5 of those. So here we are, the CircleCityCon events, and here's the alert signature, ransomware server check-in, onion domain, and check-in. So the process here is your server got on, it checked in saying I'm in there, and then it ransomwared your machine. In fact, one thing that's interesting is just sort these by time. They usually sort by the most recent event first, and there's only 5 of them, so we can just scroll through them. So at 9:49, the server ransomware started running, and then this is also 9:49. 9:49, you had 3 alerts telling you it started, then it encrypted all your files, and a half hour later at 10:15 it was done, and then it displayed the ransom note. So you can see the flow of things here, and when it displayed the ransom note, it had to do an onion domain lookup to load that page, which is, a Tor protected address. So we can find the source ID here from that, and we want to find the fully qualified domain name that it directs the user to at the end of its encryption phase. So here, this is the easiest way to do this that I found. Find the onion domain lookup events, which we already found here. So if I just go back to the alert signature, here is the onion domain lookup. So if I look at those two, there are 2 events, and they're both at exactly the same time, 10:15:12.668, exactly the same. So there were 2 alerts telling you it was doing an onion domain lookup. Now, I want to restrict the time to within 1 second of those events. I want to find the actual domain it went to, which CircleCityCon does not tell you. But all I need to do is find DNS lookups around this time. And if you click on the time, you can restrict yourself to plus or minus 1 second, which is fine. A very easy way to narrow down to this narrow time range. So I apply that, and I know I'm still okay because I had the same 2 events. Now I just want to look at DNS events in this time range, stream DNS. So I'll just put stream DNS in as my query, getting rid of everything else, because I've restricted myself to just a 1 second time period, so there won't be too many of them. And that's rude. I have 0 of them. Oh, I think I lost my time. No, I didn't lose my time. Well, how rude. Restrict the time to 1 second of those events and look at the stream DNS. Perhaps that stream DNS is wrong. Let's just have star here. Oh, I think quotes are wrong around the stream DNS. We're going to see. Now I'm going to go to source type. And here's stream DNS. Yep, it was source type equals stream DNS. That's why I don't like putting things up here. Using the mouse is better. Now I'm getting the 16 stream DNS events in that time period. And these are DNS lookups. And now I can just look at the query field. There were 16 DNS lookups in that 2 second time period. And if you look at the query field, you'll see Microsoft, Bing, those are harmless. And here it is, this crazy looking domain with server in it. That's the malicious domain that hosted the ransom note. So this is apparently a onion domain, which is news to me, by the way. I thought all the Tor domains ended in .onion, but apparently this is also a .onion domain going through the Tor network. That's the malicious domain that hosted the ransom note, is what I wanted to see. All right. Now, I'd like to know what was the first suspicious domain visited by this IP address on that date, by this end machine. So I'm going to find CircleCityCon events on that day, 24 August 2016. So let's go back to here. I'll just go back to everything. Let me change my date time range. Well, I know I want it to be on 8/24, so I guess I'll just do it here. I'll just change this to 00. .000, okay. There. And I guess I could make it 2359. 59.999, that would be pretty much all of that day, except for 1 millisecond at the end. So if I apply that, all right, and I'm getting DNS right now, but what I wanted was Suricata events on that day. So I'm going to switch to event sampling to make it query faster and get rid of this source type and look at all the events on that day. And now look at source type. Maybe source would be easier. And times Suricata. I think I want the XML Suricata. Let's try rare values. It shows me a graph for some foolish reason, but statistics show me the value. Okay. Suricata EV, yeah, EV, this is it, Suricata EV.json. Those are the Suricata events. I want to view those events. I just like using the mouse so I get this syntax right. So now I have Suricata events on that day. All right, but I should find 86,000 of them, and that's probably because I have sampling turned on. Yeah, I've 1 in 100. So this times 100 would be about right. Okay, I found the Suricata events on that day. Now I want to look at source IP, and I want it to equal the IP address of this web desk, which I found before. So source IP is here. And the address is the one ending in 100. That's the desk. There's only 400 of them. Okay. Examine the event type and get the events that load web pages. So let's look for those. Event type. Okay. And there should be HTTP. I'm not seeing it because with my sampling, I'm not seeing the rare events. I better turn off my sampling. All right. Now I should see all thousands of events. Good. All right. Now source type. Event type. There we are. And now I have HTTP events, the ones that load web pages. All right, these are Suricata alerts coming from that machine of HTTP, and there's only 38 of them. We're getting down to it. And now we look at the host names again. We're looking for suspicious host names. So we'll find host names here, HTTP host name. And again, you see innocent ones like Microsoft and Windows and Bing, and then a goofy one here, solidarityproximity.org. That's the malicious domain. The suspicious domain it went to. And now you can see the VB script itself, which is pretty awesome. If we look for VBS and EXE, we can find the actual script that was downloaded which performed the ransomware attack. So I can get rid of this date time range, go back to all times, and look for EXE and VBS. And there are 16 events that refer to both an EXE and a VBS. And if you look at the body field, you'll see a new process has been created. Okay, this looks like normal stuff. Here's a new process being created. That looks okay. This one looks okay. This one is the malicious one. You can just spot it. It's full of these obfuscated, ridiculous up capitalizations, do while is backwards. All the variables are named goofy things like J0, NE, PQ. This is malicious script, obfuscated. So that's the one. And there are a few things to find out about it. But you can find the event, and here you find the name of the first function defined in it. You can find the field length, and so on. So I think that's enough for this one. I'll stop this video and just let people work for a little while. And one thing I'm going to do is I'm going to update this this link to help you find the length of a field, because that link is down and I found a better link, which is I've saved it somewhere. Maybe I already updated it. That would be nice. No, that page is down. That's right. So I got to find that page, how to find the length. And oh, it's on my other computer. Well, I can get it. That's right. I taught this class on campus using my other computer. So it's on this one. Okay. There it is. Okay. Now I'll be able to easily get it. Okay. So I'm going to edit this page. Dots v1 in 50. Okay, and this is the hint for 4.6. There we go. And the actual link that works to keep taking things down is this one. There. Okay. There, that should do it. So if I refresh this page, that should lead to the real hint, and it does. Okay, the easy way to learn is this eval length is how you do it. All right. Anyway, good. I see people moving ahead. I'm going to put up that video then.